Hello everyone. I hope your minds are fresh after yesterday after party. My name is Piotr Stawirej, and today I would like to talk with you about the situations I've encountered during my daily work as a software engineer when it comes to the testing. What problem am I trying to solve with this presentation? I would like to answer to the common questions which were asked by people I work with, the people I mentor, during my daily work when it comes to the testing. We are going to tackle the unobvious cases we've encountered with my teams, and I would like to close or minimize the knowledge gap between the things we are learning on the conferences, from the vlogs, YouTubes, and so on, from the books, and what we may see in our daily work as a software engineers. Why is it important to solve? Of course, from the business perspective, save time and money. My personal agenda is to make our life easier and less stressful. So I hope those tips we are going to learn will help you with that. And I hope you will be prepared what you may encounter during your daily work. In some cases, I will compare them also to the existing solution and talk a bit how they differ from my solution. Why proposed solution? Because they were tested in the battlefield in the first place. So they were not created for the sake of this presentation only. For the many years in multiple projects, from the simplest one till the enterprise projects, they were applied multiple times. They solved problems we had at this time. And what is even more important from my and my team perspective, they didn't introduce new problems. And we had a happy development in the next months. I hope you will have the chance to try them in your daily work and just get back with the feedback if they also work in your environment, in your specific cases. Okay, let's jump to the first topic. Probably you are all familiar with this diagram, yes? When we have the clear separation between the unit test and integration test. The definition, the very basic definition of the unit test is some kind of the test which are not using I/O, yes, no input output, they are fast. We have like 0.1 second per single unit test, they are easy to write, I hope. The integration tests, they are slower, they are much costly in terms of the time execution, and also because they use the real-life resources, so also they may be more costly when it comes to the infrastructure. However, in real life, we may encounter tests gray area. When we encounter tests which looks like unit tests, they are easy to write, however, they are not clean in the terms that they may use some kind of the infrastructure, partially use the in-memory implementation, partially use the real-life service, real-life database, but they are not entirely so slow as integration tests. They are pretty fast, and we will discuss in a moment exactly what does it mean to be pretty fast. Did you encounter such situation? Anyone has? Okay, so what we can do? We are going to push those tests in one of those areas, so push them and work refactor to the unit test on integration test, or we are going to leave it? Who vote for leaving those tests? Who vote for pushing them in one of those groups? Okay, more people. Okay, so let's jump to the first example, first test case. Let's imagine we are starting new sprint, new iteration, and we have a task. Let's develop a library which will consist of some new functionality, it will consist of some new business logic, and this library will use the external system, and this system is fast and stable production system. The full context for this task is we are going to implement some non-trivial business logic. We have the fast internal seconds. We can imagine it responds in the milliseconds. What is more important, when we are going to run the tests against the real-life production system, they will be invisible. They will be invisible from the perspective of the customers. I mean, invisible because they will not impact the production. nothing bad will happen to the production, to the customers when we run those tests. So there will be no degradation of the production system. We are going to read only from this system, so we are not going to pollute our production. So we will not end up with some test data on production, and then we will receive, for example, some strange SMSs with test data, right? Of course, we prefer to have the testing or dedicated staging environment for this, but in some cases, from the political or technical or business reasons, at the moment, we are not able to set up such environment because it will be very costly and time-consuming. So how we can approach testing in such case? Let's write only integration tests. And if integration tests will execute in less than 10 seconds, are we okay with that? Would you be happy if your integration test will be executed in less than 10 seconds? And now, anyone has such tests, integration tests, which are executed in less than 10 seconds? Much less hands in the air. So in this case, let's revisit the time criterion. If we are running integration tests and they take reasonable amount of time, and we can avoid the duplication between the unit test and integration test, just leave this gray area of test. And in multiple projects, I had only integration tests, and they were executed in less than 15 seconds. This is my personal boundary. For the sake of the presentation, I stated that probably I would be happy if they will be executed in less than 30 seconds. Are you okay with that? You should be okay, yes? Examining your hands in the air from the seconds before. Yes, so if we have fast test gray area, just leave it. And as I mentioned, this test should be also easy to write as a unit test. So don't bound strictly like, oh God, I have to be extremely fast to have unit test, clear separation. In some cases, just go with this test gray area. But Mr. Speaker, my integration test takes already minutes. One of the common situations I've encountered, and here is, of course, refactor them, obvious. One of the common situations I've encountered is this. Anyone has the reloading the Spring Boot context in tests or seen something like this? This is like low-hanging fruit, and you can drastically improve speed of your integration test. This is the real-life example from the real project when we have the 5 tests, and due to the fact that we are reloading the test context each time, they were executed in 27 seconds. How we can fix this? We have to recall ourselves how we should write the test, how we should code. Just, in the first place, remove this abomination, I mean annotation, and then just create regular setup method in which you are going just call the SQL for deleting your test data, or regularly in the software pragmatically remove your data which are prepared for the test. So in our case, like for Mongo operation, just remove all documents. You can call some dedicated method for delete all. And those tests, which were refactored that way, now those 5 tests were executed in 651 milliseconds. For one test, maybe it doesn't make a difference. However, in the projects I did that, I've increased the speed of the integration test by 60%, from 12 minutes to 5 minutes. Imagine you are doing the heavy development on such project. In case of the mistake, which is discovered in integration test and fixed, in 10 minutes you are in the production or merge to master. In case when the tests are executed for the 12 minutes, it will take like 24 minutes or half an hour. As I mentioned, for the heavy development on such project, it makes a difference. So this is like low-hanging fruit, and people who raise their hands can already apply those in your projects. Okay, next sprint, next iteration, let's go with the use case and requirement number 2. Let's create a library, B, next library, with additional functionality, with new functionality. However, this case differs because 90% of the functionality which we require in library B is already present in existing library A. However, this functionality from the library A is internal API. We cannot use this. This is not exposed in public API. So how can we go with that? And we have some constraints. We cannot extend or change library E. We cannot extend and show this API publicly. It is forbidden. We cannot branch it. So how we can reuse it? The decision was, let's go with the reflection. This is probably the rare case when reflection makes sense. But what about the testing? Let's go with the high-level acceptance test-driven development. So high-level, because when we are dealing with the reflection, we don't want to bind our test to the low-level implementation and makes our test fragile. So each change in the implementation will make our test to crash. So let's go again with the high-level cycle. Again, only integration test. This is the second case when we have all integration tests executed in less than 10 seconds. So as you see, we are again in this gray area, but we are happy, less than 15 seconds, that's okay. And additional remark, like no redundant tests, so we are not duplicating the unit test and integration test here. So we can again go only with the integration tests. Use case number 3, next iteration, next sprint. Now, not library, but application. Let's develop the application which uses an external library. Anyone developing such system? Or? Yes or no? Yes, couple of people. And this external library has very extensive API. This is some example of one of the projects for sending emails. This is what I mean when I'm telling about the extensive API. A lot of public methods, and probably what I've encountered in my daily work, 90% of them will be not used or they are not needed for our project. Before I jump to the solution, we have very similar case when we are developing an application and not using the external library, but also the external service. And the solution for those cases are basically the same. However, what are the complaints when it comes to the testing? People who are using, developing application and using external systems, external libraries, complains that it is hard to mock, hard to stop, hard to test. A lot of methods needs to be mocked, stopped, to make tests run. Changes in external API require changes in the setup, and multiple teams and multiple people complains exactly about the same thing. Did you have such complaints in the past or current? Yeah. And how I know that you or we or other people complaining about this? Because I was the guy who was developing this third-party library. So I have the direct feedback from multiple teams, and they complain exactly about the same things. So what is the solution? Do not mock what you don't own. What does it mean? We need to create an abstraction and separate ourselves from this third-party service or third-party library. We are not want to use it directly in our code. As I mentioned, we would like to be separated for this. So how we can achieve this? Let's imagine we have a requirement. I need to access Google Maps to calculate route from point A to point B. And this is the requirement. Someone may ask about this requirement on Slack or on Jira ticket and so on. So how we are going to approach correct solution? Let's use in the first place ubiquitous language from the domain-driven design when we are going to use and express the requirements from the business point of view using domain language. This is very, very crucial. And let's stop a bit at this point. I would like us to express those requirements exactly in English sentence and exactly what you need. And in first place, I encourage you to write this in the notepad in the plain English, because multiple times I've encountered situations that developers approach me and said, okay, I need to test something, I'm gonna use this external service and I need to call this API. And my response to that was, no, what you want to do? I need to call this method, this API. No, this is not what you want to do. What do you want? Call this API. No. From the business perspective, what do you need to solve? What business problem you are going to solve? In our case, it will be get root from start location to end location. And this sentence will become our first acceptance test. And we are starting from writing this. Then, next, when we know what we are going to achieve from the business perspective, just create a port in the terms of the hexagonal architecture or clean architecture. In our case, it would be like routing service, get root from start location, end location, and return some root. Yes, we expressed in the domain language the requirement, what we would like to achieve and what we are going to solve and what we are going to need exactly from the external system. Yeah, I'm not expressing here what I need, what kind of the REST call or I need to do. From the business perspective, I have the port which express that. So now mocking is extremely easy, but it is really required or not. In most cases, probably you will see that we are preparing some expected routes, so we are preparing some test data which will be returned in our test, and here we are using some kind of the mocking library or framework like Mockito when we are mocking this port, this routing service, and then we are teaching it that when we are going to call get root with any parameters, then return expected root. Anyone is using or seeing something like this? Yeah. However, did you ever consider creating fakes and stubs without mocking tools? Anyone is doing this already? Great. What are the advantages? Just recall what is the fake. Fake is something which simulates the real-life service. For example, simulates the behavior or real service. Like, for example, database has some logic implemented. And in fact, what I've encountered during writing the test, probably you are going to reuse it multiple times on different levels. When we are going up in the test pyramid, probably the bigger chunks of our application need to be set up to make some tests. And we are going to reuse those fakes easily. It's easier to implement them manually than you think, easier to maintain, refactor, and customize. And what I mean by customization, probably we are not going to test only the happy path, because we have the tendency to test only the happy path, yeah? But what about the negative path? What about our catch clauses, yeah? Silent fail, or this should never happen, we are writing, yeah? You can run the test and check the test coverage if those paths are covered or not. 92% of the errors, critical errors, in the simple unit testing is because we are not covered the negative path. And we can, in those fakes, simulate not only the successful part, but also, for example, intermittent errors in the network. And it can be easily achieved and not so easily achieved when we are using the Mockito and other tools. And sometimes we can also extend those fakes and stubs with the verification methods, then they will become the mocks. The definition of mocks is like we are verifying the behavior on that object. In our case, or before I jump to our case, one of the common and easiest to understand implementation of the fakes is the in-memory repository. So, for example, we have like get employee by ID, save employee, and in our test, our fixtures will look like this. We will have in-memory repository, which implements repository. We have some kind of the hash map, which will contains the data. This is the very simple logic which imitates the real database. When we are getting employee by ID, it's searched in this map, or adding the employee will add to the map. This is clear, I believe, yeah? Okay. In our case, it will be very similar. We have the map, which consists of the tuple, which has, for example, start location, end location, Łódź, Warszawa, and list of the data we would like to return in our test. And here we have the logic when someone asks about Łódź, Warszawa, then we will return this list. Very, very basic, very simple implementation. However, there is more when it comes to using the stubs and fakes. This is the C4 diagram the basic skeleton of our application. So we have the application. It uses through our ports some adapters like adapter for my library, which uses the real-life external library, my service, which uses some real-life external service, my repository, which uses some real-life Postgres, Mongo, and so on. And here are our fakes. My library fake, my service fake, my repository fake. And now we can just cut off the infrastructure part in the first phase of the development of our software and just leave the application which uses the fakes. And we can already deploy it on production or pre-production. Are you okay with that or not? Who is okay with that? Who's done that? I've done this. Oh, great. I've done this multiple times. What is the advantage? It is extremely easy for us to set up such application, the basic skeleton, put this on production, let the customers know that, hey, this is our service, you can start using it. Of course, we are making a disclaimer that when we shut down the application, the electricity is down or we redeploy, your whole data will be vanished, but they are okay with that because they can give already a feedback if the API is okay. They can give feedback if the data we are providing, the test data, which are stopped, are okay. They can already start developing on their side, and they can start integrating with our application and give feedback sooner. And on our side, we just postponed all political decision about what kind of the database we are going to use and from which servers we are going to fetch some kind of the data, and so on and so on. And people were extremely happy because they were already using this. And you don't have to create the application which uses services. You can also apply it for library. And in that case, we just put the test data in the resources. And we said, okay, this is exactly the case like this from start location to end location from this simple routing service. In resources, we are preparing some kind of the return data, and customers was notified, okay, you can ask for those parameters and you will receive the data. And they are already integrating and gave feedback to us about what is okay with the data, what is okay with the format, is the API okay. Extremely useful techniques. So there is more when it comes to the using this approach. Now let's go to the another level. We are going reuse concepts we are just learn from the previous slides. Imagine that if we are developing software as I already, or test as I already show you, we can reuse the unit test we are writing on every level of test pyramid. So we can reuse exactly the same and exactly the same test, and I mean exactly the same code on every level as an integration test, and even with the small trick, we can use them as an API test or even through graphic user interface. Exactly the same test. And how we can achieve that? This is the skeleton of the simple unit test. When for our application, this will be very, for the sake of the presentation, very rudimentary application, which has only one method, do something and return a result. And this application will use some kind of the repository, service, event publisher. In our setup method for this test, we are going to inject our fakes we've just created. So in-memory repository, in-memory service, in-memory event publisher. And here we are building our app, my app, new instance factory method, and we are injecting those test dependencies. Everything clear at the moment? Yeah. And now, then this is how we are running the test. So we are just calling this method, asserting, and so on. This is less important. Pretty clear, I hope, yeah? Okay. And now we can reuse those as an integration test. How? Let's just create the integration tests. They have in name IT, so we know it's integration test. And we are just going to extend the base test class. And in the setup method, we are going to inject production dependencies like Mongo repository, external service, and some real-life application event publisher, yeah? And that's it. It will be transparent for the unit test, which are our base class, and the all unit tests will be executed, but with the production real-life dependencies. Is it clear? And we are just write our test once. Let's push it further. We can create an agent, the system abstraction, from the top level for our behavior, which is our interface in our contract, app, do something result. And this agent will know how to call our behavior, which is do something, from the graphic user interface or from the REST API. This concept can be tricky, so let's take a look from the another diagram for a second. So we have our acceptance test. They will be run against and test my app. And this acceptance test will use Selenium GUI agent or REST API agent, which implements our application abstraction, do something method. And our unit test will be run using this agent. How it will look like. For example, we would like to run exactly the same unit test, and I've did that multiple times, through REST API in our application. So we have like Spring Boot test, when it writes the whole Spring Boot context. Here we have the, again, extending our unit test base class. Here we are overriding some authorization tokens, so we are simulating that we are the valid user, and we can call this API. And here is the first difference. We are not creating the app itself as it was in for the unit test or integration test. We are creating here an agent. So app REST agent, new instance, when we are injecting those required web test client, which will make the calls through the REST API. How it is implemented? The REST agent, this system abstraction, implements again our app interface, do something with result, and this is the implementation. You can use any kind of the REST library to make a REST call through API on some URI, and here we expect some result DTO, and we map it and return our domain object, which is result. Is it clear? More or less? So we are able to call our behavior, do something through REST API, but the tests are exactly the same. They don't know. We fulfill the contract, which is do something and return result. For the test, it is transparent. Of course, the experience would be incomplete if I wouldn't show you how it looks for calling something from the GUI interface. So here we have the app GUI agent, and method do something is now using like Chrome driver, which knows what has to be clicked on our user interface, what has to be sent, and how to get the result from the visual part of our application. If you would like to examine in details how this concept works, on my private GitHub repository, there's a financial system which implements exactly this concept. You can Google it later or ask me later. Contact, yeah, pictures taken, okay. Of course, if we go with this approach, we will not build the test pyramid, but the test square. And in some cases, we just would like to skip some of those tests. Of course, again, if those integration tests will take less than 30 seconds, 15 seconds, live with that. We can live with that. However, for example, JUnit, it is very easy to distinguish if we are running currently unit test, integration test, for example, based on the name. And in some tests, if we would like to skip them and leave them only as unit test and not as integration test, we can run the assumptions functionality and check if it's unit test, then run only as a unit test and skip in the integration test. Okay, next concept, next use case. We are getting through the more harder use cases. But this is the morning, so I hope we are all in fresh minds. Time-dependent code. Anyone is dealing with the time in their application? Great. So when we have some class and some method, and we have the direct call for the time instant now, we know that it is hard to test. And what is the proper approach? Who knows? The concept is, and general rule, that we should inject the cloak and have the explicit dependence on the time, right? And you have that? Yes, great. And now it's extremely easy to test, because in the test itself we can prepare some fixed clock with some fixed date, fixed time, and now it's extremely easy because we are injecting our clock as a dependency, execute some behavior and test it. Pretty clear for pretty simple use cases. However, what if we have a legacy system and it is heavy time dependent app? What I mean when I'm saying heavy time dependent app, dozen and dozen of classes which uses the time, and now there is an issue with the testing, because on the higher level of the test pyramid, we probably, as I mentioned, has to set up a larger chunk of our system. And now, when we have the components which depends on time, and they obtain the time in very different ways. So for example, instant now from clock, local date now from clock, and so on and so on. We need to do the heavy refactor in the first place to make it testable. So first thing we are going to maybe use is mocking static instant now. Anyone is doing something like this or not? Great. It is not so easy already for this simple case, because not only the instant now has to be mocked, but also when you are going to run those tests, you will learn that some internal API also has to be mocked, because it will not work. But what about the testing the time flow simulation? It's getting even more harder. What I mean about the time flow simulation, we have a process which starts, for example, at 8 AM at the morning and runs till the midnight. So how we are, and it emits some events at certain points of times, and we would like to assert if those behaviors which are manifested through those events are executed or called at exactly those points in time. And we have, for example, some kind of the scheduler which emits those events when this process is running. So in fact, what we would like to have is single clock. So we would like to have single clock for the whole application, immutable in production, mutable only in test, both fixed point or time flow simulation. Maybe we will be happy like with the injecting with the annotation the logging mechanism. So only inject our time provider and not make this explicit the clock as a dependency. So no redundant parameter passed everywhere. And we would like to prevent usage of alternative time providers. Is it possible? Yes, it is. After one project, when I had this situation, I came up with the library TimeFlow, which is the wrapper for the current system provider in Java, the current time provider in Java, and it fulfills all those requirements. So in the production code, we can call right now the time instance now, or if you would like to go with the injecting the clock, which is the preferred way, we can reuse this as a clock. However, it's extremely easy now to deal with that with the legacy system. We are just searching all times providers we have currently our application, delete them all, and replace with that. No heavy refactoring is required at the moment. Now, in test, we have the second flavor of this library, which is test time, and now we can easily set up the fixed clock, simulate jumping to the specific point of time, or simulate the time flow. This is the example of the most complicated cases about the time flow simulation, which is already simple, when we are just setting the fixed clock, setting the jump forward, so we are going to jump every 1 minute. We are setting, of course, the end time of the process, and we are saying that 1 minute in our test will have to be like 100 milliseconds. And then we are running our background process, just to call the method for simulating the time flow and do the assertions. And how we can prevent using other time providers? JUnit. Anyone is using JUnit for their architecture? Great. You can reuse it also for checking if we are not using the test time flavor in the production, and we can forbidden as a simple unit test for using like instance now, using local datetime now, local time now, and so on and so on. So we can prevent in simple unit tests anyone, there is newcomer in our team, will use like instance now, the unit test for which are now which are using the arc unit will fail, and then we will prevent using the other time providers. Okay, next iteration, next sprint, we are now going to develop an application and test async code. So we are going to create a subscriber which reads content from the queue in a thread, process some messages, process them, map them to the other format, and for example sends content to some kind of the external service. And here we have some kind of the publisher which publish on some queue. Anyone is developing pretty similar application with dealing with queue? Okay. So what I've seen when it comes to the testing, we are preparing our queue. We can use the test containers or our fakes, whatever, what is easier for us. We are creating the mock for our external service, yes, for this part. We are creating the fakes for the subscriber. And here we are preparing the test data, which is like message 1, message 2, message 3. We are executing our subscriber in the background. Here we are putting time sleep, 5 seconds, and we are asserting if service mock, so our end fake, will receive process 1, process 2, process 3 message. But there is a problem with this approach. Where? Here. Anyone was seeing in the test thread sleeps? Has something like this? Don't be shy. What is the problem with this approach? When we have a dozens and dozens tests which rely on some delay, we have very long running tests. How we can solve this? We have the technique which is called sampling. And we are going to sample our system with the probe. Our probe is our service mock, and we'll check if we are received already those 3 messages. So what is the sampling? We are going to poll after, with interval, for example, 100 milliseconds for the system state, and checks for at most 5 seconds if we already received the correct system state. And if not, it will fail. And in 99.9% of the cases, it will be in the milliseconds and not waiting for this 5 seconds. We have 2 techniques, in fact, sampling and listening. So when we need to test some async code, we need to have an observable effect. And through sampling, we repeatedly polling the system for the state. And we can, for the systems which sends events, we have the technique called listening, and we are listening for the events which system emits. But what if we have the same system state at the beginning or at the end? What if we need to test the no visible action? So the system state at the beginning of the test is exactly the same. How we can test that? We need to trigger behavior which we are able to detect. So we need to ensure that system has started, because if nothing happened at the beginning of the test, maybe we made a mistake, and in fact the test should fail, but it passed because the state is the same. So in our situation, validate no visible effect, we, for example, publish on our queue messages which should be ignored. And then in okay, we should publish the message which should be ignored. And now our probe will look like, in the first implementation, that we expect that we received message count 0. But we, as I mentioned, there is a chance we made a mistake. The system hasn't started, and we received messages 0. So how we can fix that? Let's trigger behavior which is detectable. So let's mix those ignored messages with message which will be processed. Now, our probe will have to have at least 1 message to be processed. So service mock received message count 1. So we know that our system started, processed something, message which should be processed are processed and ignored. No visible action is also tested because we have only in assertion process to message. Okay, at the end I would like to give you one, and in fact two, heuristics which is extremely easy when it comes to the testing and what to test and how to approach this. The number one heuristic which is extremely useful is single responsibility principle. It states that class should have one and only one reason to change. I like the second definition, class should be responsible before one actor. My comment is like on whatever level of abstraction you need, function, class, module, abstraction should encapsulate single behavior. But you should raise hand and say that this is pretty vague definition. So I will give you something tangible. Let the cohesion guide you, and we can measure the cohesion. So we would like to have the classes and modules which are high cohesive. So it means that each method manipulates as many class fields as possible, high cohesion where methods and class fields depends on each other and are logically connected. If some class fields are used by subset of methods, probably we need to extract a separate class, separate behavior, separate tests. And this approach simplifies writing and creating the test. This is the simple implementation of the stack when we have two fields, top of stack and elements. And let's examine the methods here. We have the method size, which uses the top of the stack. We have the method push, which uses top of the stack and elements field. We have the pop, which uses top of the stack and uses the elements. Is it high cohesive class or not? Who votes that this is not? Who votes that this is high cohesive? Okay, yes. We have the high cohesive class. This is the single responsibility principle is fulfilled. And we can check this not only in the pull request in the code review, but for example, we can enable LCOM metrics in our Sonar cube when we are going to validate if our classes are high cohesive or not. And then we have the single behavior, and it's much easier to write the test for the single behavior. If we will have multiple fields in our class, and some part of the fields were used by some part of the methods, and other part of the fields will be used by other part of the methods, then the cohesion is low. We see already that we have two behaviors. And when we are mixing two different behaviors, it is hard to test already. At the end, I would like to give you a takeaway that testing strategy is a conscious decision, the same as the architecture. Anyone is using architecture decision records? Great. Did you, at the beginning of the project, putting what kind of the architecture is going to be used? No. The second question, do you put also in this architecture decision record information what kind of the testing strategy is decided to be used? No? So I encourage you to revisit how to use the architecture decision records at the beginning of the project, because this should be a conscious decision. Not only the architecture hexagonal, pipe and filters and so on, but also a testing strategy. Are we going to use test pyramid? Are we going to use honeycomb with only integration test? Are we using anti-pattern, which is ice cream cone anti-pattern, reversed pyramid in case when we are dealing with the legacy system? Because in that case, this is in fact the way to go. Okay, thank you very much for your time. Please rate this talk in the inventory app. This is the link for the presentation. If you need my help, I'm currently open to work. If you have any questions, I encourage you to approach me after this presentation and we can have a chat. If you have the questions later, just ping me on LinkedIn. I will try to answer. Thank you very much and good luck.